This is Geometry 4.6a. We're going to talk about proving triangles congruent again. This time we're going to use ASA, sorry I said that wrong, ASA and AAS. Those are the two ways we're going to prove triangles congruent today. S has to be the included side, or S is the non-included side. The order matters. So let's come on down here and take a look. We have angle A. Angle A is congruent to angle D. They both have one tick mark. AC is congruent to DF, segment DF. And angle C, we have two tick marks, and F has two tick marks. So notice how how this included side, the side in between the angles, is in between the two angles that are provided. The side is in between the angles. So this is side, angle, side. My goodness, I'm saying this all backwards. Angle, side, angle. Angle, side, angle. So triangle ABC is congruent to triangle DEF. I want to show you something. If we have an angle, that angle is not allowed to change. And if we have another angle, that angle is not allowed to change. And we have the side in between those angles. That's not allowed to change. If we were to come up to this and draw in the other sides, how many different triangles are possible? If we were to extend the sides, could we create different triangles? Or are we guaranteed to all create the exact same triangle? If I extended this side out, how far should I go? When do I need to stop? If I was to extend that side, am I allowed to go forever? Who knows how long that side is? Doesn't that side have to meet this side? So I'm going to stop right there. I have to stop right there. There's only one triangle that is possible giving angle, side, angle. Every single time you are going to create the same triangle if these were the angles you're given with the included side. So that's why we can prove triangles congruent, because we only have one option. Let's come on down and look at angle, angle, side. Angle A is congruent to angle D. Angle C is congruent to angle F. And side BC is congruent to side EF. Notice this time, we're not talking about the side that is in between the A's. We're talking about the side that is not in between the A's. We call that the non-included side, not the side in between the A's. The included side is the one in between the A's, in between the angles. This is the side not in between the angles. So this is the non-included side. That's why the S goes on the outside of the A's. So the order matters. So triangle ABC has to match triangle DEF. This one's a little harder to demonstrate. But if I have this angle, and I have another angle, you can't change those angles. Those angles are in concrete. Now I'm going to extend this side out. I can extend it out as far as I want because I have angle, angle, then a side. Angle, angle, then a side. This angle here could actually be anywhere. We could put it close here so it comes over here, but then we're not reaching the end of this segment. We have to reach the end of the segment. We've got to be right here perfectly in line so we can extend it out and reach those. Okay, so given this angle and that angle and the non-included side, we can make exactly one triangle. There's the side that we're given. 2 A's and the non-included side create exactly one triangle. I don't have another option to make. I'm not allowed to make the angles any bigger. I can't make the red side any longer. There's no other location this green angle can go for it to touch this corner and to touch up here. It has to be right there. So that's another demonstration of why angle, angle, side works. A little harder to visualize that. Side, side, side is the easiest one. But let's come on down here and try these examples. What are ways that we can prove triangles congruent? We've learned side, 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 angle, side, and now today we've learned about angle, side, angle, and angle, angle, side. Those are the 4 ways we've learned to prove triangles congruent. Can we use any of those methods by this given information? What does this given information tell us? We have a pair of angles congruent. That's right there. We have another pair of angles congruent. That's guaranteed. So we're going to most likely use something with 2 A's in it. Do I know any sides are congruent? Is there any information that tells me sides are congruent? Do I have a midpoint? Do I have a reflexive side? Not enough info. No sides must be congruent. I don't know about sides. I need to have a side. In every example up here, I have an S. I don't have any relationships to my S's here. Okay, how about this one? What information do you see? I have a pair of angles the same. I have another pair of angles the same. Do I have anything else definitely the same?
The reflexive line.
We have the reflexive side the same. So which one of these methods are we going to use? We have 2 A's in one triangle and a side in that triangle. Is it in the pattern of ASA or is it in the pattern of AAS? The blue, the green, then the side. The side is not in between connecting the angles. It's outside of that. Okay, what about letter C? I have a pair of angles the same. I have a pair of sides the same. Do I know anything else? With an A and an S, I might be using this. With an A and an S, I might be using that. Or maybe even that. So what's the other bit of information we know for sure? Anybody willing to gamble? What do you think? We have our vertical angles. We know that for sure. So now we have two A's in both triangles with the side that connects them. So angle, side, angle. You want to look for that. What about our last example? What do you see? Because we have an angle the same and a side the same and another side the same, look at our order. We have a side, and an angle. That is not one of our four ways we can prove triangles congruent. The A is not in between the S's. The A is outside the S's. It doesn't even touch the red side. So, not enough information. We can never prove something by SSA, otherwise known as ASS. That doesn't work. It's not one of our methods. Right. Let's come down to our last example on this page. We have triangle STW. And we have triangle VWT. What do you notice about STW and VWT? The triangles are overlapping. A lot of people make the mistake and they want to talk about these vertical angles. But the vertical angles are just a mirage. It's not really there. We're talking about STW. We're not even talking about U. So it's often best, if the triangles are overlapping, to draw the triangles separately. That helps you label it. So this is S, this is T, and this is W. And for this one, this is V, this is W, and this is T. We know that S is 60, and we know that V is 60. We know that T is 90 degrees. We know that W is 90 degrees. So that part we know for sure. Do we know anything else? It might be easier to see it in this picture. But do we have anything else for sure? Things we like to talk about is, do we have a midpoint? Do we have parallel lines? Do we have an angle bisector? Do we have a reflexive side? Hey, a reflexive side. Both triangles, if we trace out STW and we trace out VWT, don't they both trace over this TW? Don't they both contain TW? So what method are we using to prove the triangle is congruent? Two A's and the S that's right next to it. Angle, angle, side. Okay, on the flip side, what do we see here with example 3? I see parallel sides. What are we supposed to think about when we see parallel sides? One of these angles has to happen if we have parallel sides. That's what we're looking for. It's one of these angles. Corresponding alternate interior, alternate exterior, consecutive interior. Well, for much of this unit, this is the most common one we see. We see a zigzag. That's going to give us this angle here being congruent to that angle here. Alternate interior angles. We also have the other A's that they gave us. And we, of course, have the reflexive side. So which method are we going to use? Remember our choices. Get used to writing out those choices, and it'll be easier for you to start to be able to identify them. Which method are we going to use for this one? Look inside one triangle. Don't worry about the other triangle. Look inside just the one triangle. We have an angle. We have an angle. And we have the side that's connecting those angles together. So angle, side, angle. We don't have the parallel sides being congruent. They're not labeled as congruent. They're only labeled as parallel. Parallel does not mean congruent. Okay? Down here. Triangle JRM is congruent to triangle XYZ. You should draw your triangles out. Label your triangles JRM, XYZ. Label your triangles. Now you mark up your triangles. JM has one tick mark. XZ has one tick mark. Angle M, angle Y. Hey, look right there. They're not in the same position. M is off of the one ticker, but Y is not off the one ticker. Not congruent. In the next example, we have our two triangles. Label them JRM, XYZ. You can put the letters in any order you want, doesn't matter. RM, we got to find that. That's right here. YZ, angle M, angle Z. They're the same. Angle J. I use a different number of tick marks. Is congruent to angle X. So which method are we going to use if we're thinking about one of these choices to prove triangles congruent? Which method are we going to use? We have an angle followed by another angle followed by a side that is not in between those angles. AAS. And then this one might be pretty obvious to you. JRM, XYZ. JR is congruent to YZ. That's okay. It doesn't have to be pointing in the same direction. RM congruent to XZ or ZX. And then JM is congruent to XY. So notice how they all have a one ticker, two ticker, and three ticker. So that is side, side, side. We prove the triangle is congruent given that information. Here we're talking about the third congruence that's needed. I'm given one bit of information, another bit of information. What's the third bit of information I need to know if I'm going to use angle, angle, side to prove it? Well, come over to your shape. I have a pair of angles the same. I have another pair of angles the same. Now I need to use AAS. AA, now I need to use and find a pair of sides. Well, there's actually two correct answers, but there's one incorrect answer. Angle, angle, side would probably be the most common one, right there. You could possibly say angle, angle, and discuss that side. But we'll just say EF and RT. You could have said ED and RQ. That would not have been wrong. In both situations, it would have been angle, angle, side. Let's try another one. It really helps to have the figures drawn. I'm going to draw them out. This would be for question B. We have EDF, DEF, and QRT. I know that E is supposed to be the same as R, and EF is supposed to be the same as RT. I'm going to use ASA, angle, side, angle. So what's the other bit of information I need to use ASA? I have a pair of angles, I have a pair of sides, so I'm looking for another pair of angles. What other angles am I going to talk about? I have these two as a choice, or I have those two as a choice. Does it matter? And yes, it does. To have the angles with the side in between, we have to know that angle F is congruent to angle T. That's my only choice, to get angle, side, angle. And then the last example, last one of the day, DEF, QRT. I know that angle D and angle Q, DE, QR, I'm supposed to prove this by side, angle, side. I have a pair of angles, I have a pair of sides. I need two sides with the angle in between. I'm going to need DF to be congruent to QT. That's my only option, to get the angle in between the two sides.